Hello, and welcome to the Florida Peanut Podcast. I'm Noah Walker with All Things Visual Marketing, and joining us today in studio, we have our fearless leader, Laura Fowler-Goss, and our incredible assistant today, AnnMarie. Laura's more than capable daughter, and she's here with the hard-hitting questions today. And those hard-hitting questions will be for our guest, Dr. Sheeja George, who is a research coordinator and biochemist for University of Florida IFAS, where she works at the North Florida Research and Education Center in Quincy, I believe, right, Dr. George?
That is correct.
Well, welcome, and thanks for joining us today. We've had a great conversation up to this point, but we're looking to put as much information as we can from you out there, because you speak at a very high level about some real high level issues and projects that you're working on. So why don't you tell us a little bit about who you are and what you do?
Sure. Thanks, Noah. And hi, Laura and AnnMarie. And it's a pleasure to be out here with you, and especially representing UF IFAS and the North Florida Research and Education Center. You're right, I'm located in Quincy, but North Florida Research and Education Center has two other centers in Live Oak and Mariana as well. I am a research coordinator, and my main job right now is to forge large teams to develop research questions and to develop grants and programs and go after funding. So that's my main job here at the NFREC. However, I came to the NFREC as a postdoc. My training is as a biochemist, as a plant biochemist. And I played in horticulture for a couple of years before moving to agronomy. And my overarching theme of my research has been, cropping systems, improving the viability and sustainability of cropping systems from two perspectives: improving profitability for our producers and improving environmental sustainability. And for that, the overarching theme are threefold. One is year-round crop on the ground, keeping the soil covered, keeping live roots in the soil, and minimum disturbance to the soil. So my research and my team's research has been within the framework of that. And again, I want to remind that I'm just a person here, but there's a huge team out at the NFREC and at UF IFAS that makes all this cool research possible.
Excellent. We are just so thankful for the work that you all are doing. I won't put you on the spot because we didn't ask this in the pre-interview conversation, but there's hundreds of thousands of dollars every year that funds peanut research specific. And I would imagine not dozens, but really a lot of people that contribute to that collaboration for those projects.
Absolutely. First of all, I wanted to express our gratitude for all the research dollars that come from the Federation and from the various checkoff funds. And that keeps a lot of pertinent questions alive, and we are able to answer those questions for you. I just wanted to say that if you come out to the North Florida REC, whether in Quincy or Mariana, this is how I explain our center to people. Every office, every room is a different expertise. So you have an agronomist looking at crops and how they grow and physiology. And then you have a plant pathologist, you have an entomologist, you have a soil and water specialist, you have a breeder, and you have a geneticist. And every room is a different specialty. So if I get stuck with a problem, I just get up and go next door, and boom, I have an answer and I have a solution, or at least we can brainstorm. That's the beauty of working out there at the REC. But yes, there's dozens of people working on peanut questions, and peanut is not growing in a silo, it's growing with other crops. So how peanut interacts with other crops and so on and so forth. So there's dozens of researchers trying to help our producers succeed.
That's right. And I will mention that we try to tailor this podcast to the producers, but we recognize that when we put it on the internet, it's open to everybody. So thank you for your layman terms and saying things that are very impactful to the actual farmers, but also that can provide education to whoever is listening. So thanks for that. Something that was really impactful that you said was the success for the producers in terms of profitability and sustainability. And that theme is really, really overarching to everything that the Federation does. And we appreciate people in your position that recognize that. So thank you very much.
Yeah, those two words are huge. So let's get into some of the meat and potatoes of what you do. What's a recent project that you've completed that maybe some of our farmers would have worked with or should know about coming up?
So, like I said, my main job is to bring large interdisciplinary teams together. I mean, people with different expertise coming together. So one of the projects that's about 5-6 years old now is a $15 million USDA project, United States Department of Ag project on an oilseed crop, just like peanut, another oilseed crop, but it is from the brassica family, from the cabbage family, if you will. But this is an oilseed, just like a little mustard. It's a tiny mustard, but it's non-edible. It's not for human consumption. So here's the cool thing about this crop. You grow this crop in the winter when you are not growing your peanuts or your cotton or your corn or any other crop. It grows in the winter when a lot of our producers are not growing anything and the land is bare. And here's an opportunity for producers to grow this in the winter, generate revenue out of it. Otherwise, they would not be making anything out of that land in the winter. And this oilseed crop, this tiny mustard, can be harvested, crushed for oil, and it's not edible, but it goes into the renewable oil stream for sustainable aviation fuel. And there's a big, big focus and demand for sustainable aviation fuel and renewable diesel. And once you crush the seed and get the oil out of it, whatever remains is very high in protein. It's about 40% protein. And guess what? Yep, 40% protein. And guess what? Our Southeast, like Florida, Georgia, Alabama, this region is hungry for protein in the winter for our cattle. And so we tested it in cattle, and we can use it as a protein supplement. So the entire product is used. There's nothing going to waste. And that was a very successful project. We did it the grant was funded for 5 years, but we started doing preliminary work even before that. And finally, in 2022 fall, it's in the ground right now. There was commercial acres launched with our industry.
Awesome.
Yep. And so it takes a while for, an idea like a tiny mustard to become a giant enterprise. Yeah.
And that seed again is called what? Brassica
carinata. I'm sorry, I should have said it. It's called carinata, and it's from the brassica family. So Brassica carinata. It's very similar to canola. In fact, if it's not a trained eye, you could mistake one for the other. It's beautiful yellow flowers. If you come out in March, it's a nice photo op, by the way. It's lovely yellow flowers.
So you'd have to be careful in harvesting that for a layman like me, right? I go to cook with Brassica carinata and end up setting my whole kitchen on fire because it's used for jet fuel, not cooking oil. Well, great. That's an incredible project. I think, AnnMarie, did you have a question about how a project like this comes to fruition?
How does the scientific method that kids learn in school, is it the same as the professional research method?
AnnMarie, you'll be glad to know, and your friends as well, that it is exactly the same thing. What you are learning in school today, asking a question, developing a hypothesis, checking to see if it's a testable question, can I really test it? And then setting up a design and doing the experiment and observations, conclusions, it's exactly the same thing. Now, your school project may have to finish in a few weeks. The only difference is that ours may not finish that fast. We have to test it. For instance, if you're doing a project with peanuts, we have to wait for the whole peanut season from seed to plant till the pods develop. We have to wait for the entire season, see how it works out. So the time is the only difference, but the steps are exactly the same. You'll be glad to know. So whatever you're doing in school, is what you're going to apply in your professional life when you grow up. So that's exactly how we do it.
It's very, very cool. So where do the questions come from? The minds of researchers who are familiar, or from the industry? And then this just came to me. Does every question require a hypothesis? Because that's what you think will happen, right? Or can you just say, well, what it is, what it is?
Ask a question and roll with it.
That's a great question. So it's a mix. So here's the thing, Laura. There are so we do two types of research. One is applied research and one is basic research. And let me take a moment to explain this for whoever. So the applied research is, Laura, I come out to your farm, I see a problem, and Laura, you say that, this has been a problem. It's probably a disease. It's probably, it's not getting enough nutrients or whatnot. So we're like, okay, so you brought the problem to us. You did half the job for us actually over there. In this case, it's like you said that there was a problem and then we developed a question around it. And that's applied research. We see a problem, we develop a quick experiment. But then there's a basic side of it. And those are aspects like breeding and developing new varieties and cultivars. And that is, you have to go down to the DNA of it, right? It isn't something that I can see, but I have to study the DNA of it. I have to see how I can modify, how I can breed this for better yield, better disease resistance, and things like that. And that basic research needs to continue. It is probably something that's not ready for prime time in several years. But unless we have that basic foundation, basic research, like how are these proteins working and how's the DNA interacting and all that, then we'll never have enough ammunition, if you will, or enough fuel to fuel this applied research. So now you bring us a problem. We're like, oh yeah, we have some basic research done on these things. Let's take it off the shelf. Let's try out a few different things on the farmer's field or in our plots, and then we come up with an answer. So those are the two types of research that we do, and they're very different in their timelines and in how we approach it. I hope that answers your question, but
I think so. And speaking of timeline, between when there is a question, that dictates a research project through commercial application, and I'm certain that it's different, based on what the project is, but talk us through that timeline, because the farmers, they want to be profitable. They want to be, very sustainable in their operations on every level. They want to be sure that the land will continue to help them produce for many, many years. And they want the money to be there to help them continue what they're doing for many, many years. So talk us through the timeline of, how the projects go from conception to commercial application, and some basic, maybe even some examples of some peanut research that you've seen done, or something like that we can really gain an understanding of.
Absolutely right. I'll do that. So some examples of, say you have a new fungicide on the market or a new product. Those are the lower hanging fruits, if you will. You test a bunch of products on a few varieties of peanuts that are out there, and you test it for a couple years, and you test it in multiple locations. So let me just so if you have multiple years and multiple locations, then you get more power in your data set. If I do it only in one location, then yeah, because that may be true only for a small. So what I do is, if I'm doing 2 years of research, I do it in, say, 4 locations. So really 4 times, how a scientist looks at it is, I'm getting 4 times 2, 8 data sets. So that's a more powerful data set. Then I'm like, oh, this is going to be true across the entire Florida, not just the Panhandle, not just the Suwannee Valley, but maybe across. And so I have more confidence in that data. In 2 or 3 years, I say, yeah, this product is good, and boom, it's ready for prime time. Now, on the other end, something like breeding, something like Dr. Barry Tillman does.
Yes.
You had him earlier on your podcast. That takes, several years, because
It is much different than a second grade lima bean in a Ziploc bag.
Exactly.
Yeah.
You are exactly right. So that's going into the DNA of it. That's trying to understand. So he makes some crosses. He takes parents and he crosses, and then the siblings and the next generation and the next generation. Then here's what he has to do. That's in the lab. Then he has to prove it in the field. So he takes it out to the field in many locations, and then he looks at it, and then he has to test it over time, and over time he keep making these crosses till he gets what he's looking for. And this could be for higher yield, it could be for disease resistance, it could be for drought tolerance, use less water. There's just so many of these questions that a breeder has to look at. Again, the problems are coming from the field, the problems are coming from the producers, and they're saying, you know what, there's disease, I'm not making enough money on this variety. So so constantly that pipeline. So Barry Tillman is constantly creating that pipeline. But if he starts today, it'll be 7, 8, 10 years down the line before he gets a successful, which he released a successful variety this past fall. And that is a result of a lot of years. So there's different types. There's if there's let's say disease that's broken out, there can be quick remedies to it. Hey, we have a few products, let's try these products. In a couple of years, you have an answer. But then there are some that are a little bit more involved, if you know what I mean.
So if the research project starts in the laboratory and then is at a small plot at the research center, then what are the steps after that? I assume you have to have buy-in from the producers, and hopefully they're eager to work with your groups and say, sure, come out and plant 5 acres or talk to us about that.
Exactly. So, a concept starts in the lab. We do it in our small plot trials, because that's our proof of concept. If it doesn't work in a small plot trial, then it's not probably going anywhere. So we do it for a few years, multi-locations, and we're like, okay, there's some promise in this method that we're doing. It could be a product, it could be a practice, it could be, because products are easier to go commercial and launch, because here's the thing, this is the rate you spray, but a practice, changing a practice takes a longer time. So that's the difference between a product and a practice. Even if somebody comes to you and say, hey, use this product, it's a lot easier. But somebody asks us to change our lifestyle, it means it's different.
I wrote down that you improve crop production and cropping systems. And I'm thinking, but my granddaddy didn't do it that way. Whoa.
Yeah.
Exactly. So changing our life, it's almost like, you could be healthier if you changed your lifestyle. But can I just get a pill instead? It's a lot easier to pop that pill in rather than change. However, so here we started a small plot research. We are satisfied with what we see. And then a lot of our producer friends are always willing to partner with us to they give up a piece of their land, and they have to accommodate us because we go with our stuff and we go with our little thing. And we always try to communicate with them that this is what we are planning to do. And more our research is going on farm so that we get proof of concept sooner.
Right.
And we work with the producer, so we know what the real world issues are. Many a times we take it to a 5 acre, 10 acre strip, and we see, it's not working exactly the way it worked in a small plot. So we need to tweak it a little bit. But guess what? The beauty of this whole thing is the producer is right there. And oftentimes, the producer has excellent solutions for the problems that we are facing, because he or she is right there in the middle of that in the real world and saying, you know what? I would tweak it this way, or this is what I have seen on my land, in my field. So maybe this is what you're missing. And then we are like, let's take it back.
Wow, that's awesome.
So, the producer has such a big role to play, because nobody knows the land like the producer. So that's really the progression of research, from lab to small plot to large real world out there, then circle back and forth a little bit before it's ready for prime time.
Awesome.
Nice. And that's a great, I mean, with the project that you told us about with the Brassica coronata seems like it's, it answered the question of what do I do with my land whenever it's not in use? How can I be more efficient and higher in profitability and without destroying my ability to get into my cash crops, right?
That's right.
Exactly right.
Essentially, how can I rotate with another cash crop? And it sounds like it's not just great for the farmer, it'll be great for other farmers as well as, a whole, maybe possibly a whole new industry in terms of jet fuel and biodiesel. So incredible.
Cool. Very cool.
Yeah, very cool. What are some current projects? So that one has been over the last 5-6 years, is now on commercial acreage this year. What are some current projects that you're working on?
Okay, so there's a big, exactly like you said a few minutes ago, this fine line between profitability and environmental sustainability, neither can be compromised. So the idea to become more efficient with our input, be it water, be it fertilizer, be it fungicide, insecticide, and that affects the farmer's bottom line. And the cool thing about that is it ends up with lesser load on the environment too, with be it fertilizer runoff or insecticides, pesticides that are remaining in your soil and so on. So there's a big focus on climate smart, what they call, you can call it whatever you want, but the phrase is climate smart ag and climate smart forestry. And so there are a lot of projects that are coming up. So what I'm involved a lot in is to bring teams together. Again, teams with different expertise, not just a single track, but people who can use robotics and artificial intelligence and people who can use precision ag, and then people who actually know everything about a crop and crop physiology, how a crop grows, because you can't move away from that concept. And so bringing these teams together to do more efficient ag, efficient with resources, efficient with time, I call that empowering the producer to make decisions, real-time decisions, empowering the producer to be more efficient with their resources so that their bottom line looks better and better. So those are some of the, and fertilizer input and fertilizer, becoming smart with your fertilizer is such a big focus these days. And it's true for any crop.
Yes. Wow. That's awesome.
That is awesome.
It's encouraging.
It's incredibly encouraging. And over the last year, the theme of what we've heard from some of our researchers and experts in farming and planting have all talked about inputs, right? Input costs going up while the price hasn't always followed it up, leaving farmers in a pinch. So that's incredibly important research. And we can't wait to see it put in practice and in use on the commercial side of things and in our everyday friends and farmers' lives. I know that Ms. AnnMarie had some more questions for you to round this out. Ms. AnnMarie, would you like to fire off some of those hard hitters?
About how many research projects have you done?
Oh, you should have tried an easier one on me, AnnMarie. I would say hundreds of research projects, but I do want to tell you, AnnMarie, it's not me. I represent probably hundreds of projects, but there's a team. There's a very, very smart team of different kinds of scientists out there, people who work with bugs, people who work with diseases like plant doctors, and people who work with robots, and people who work with tractors and how to put out these medicines or chemicals on the peanuts so that they can grow better. So, and then breeders like Dr. Tillman who make new varieties. So it's a team out there, but I personally have been part of various research projects that are looking at the system, how to make a crop grow better with less. So hundreds to answer your question, but definitely come out to our REC, AnnMarie, you and your friends, and I'll give you a tour.
That'd be fantastic.
What inspired you to become a scientist?
Okay, so AnnMarie, about 16 years ago, I lived in India. I did not always live here, and I was very interested in chemistry. And so I did my undergraduate in chemistry, and I took that to the next level and went into a master's program in biochemistry, kind of combining biology and chemistry. And I did a project. I worked with chickpeas, like garbanzo beans, and I got a protein. I extracted a protein out of those seeds, and found out after doing a lot of research that that protein from garbanzo beans could be used to kill some insects that were attacking stored wheat and rice. Like, once the farmer harvests it and puts it in these big bins, there are some insects.
Dr. George, she's going to be rubbing hummus around the whole house.
Oh my gosh, no. Hummus is a lot better with your pita, but then this one, and that, when I thought about that, AnnMarie, I thought, okay, my little research project, which I thought would not go anywhere, can actually solve a farmer's problem out there. And that kind of really inspired me. And I went on to do a PhD. I did more on that same line of work, and I never looked back. And that's why it's really cool to solve real world problems and to see that you can make a little difference.
That's awesome.
Sounds like it could solve some peanut packers and shelf facilities problem as well.
The honor of coming up with something that can really benefit society.
Real world problem.
That's very exciting to me. And to be honest, I'm a little bit jealous. I'm not sure if I'm helping the world.
I think you are, by bringing these, you represent the producers, and you bring all these real world issues to us. Otherwise, we could work all day in a little silo and be happy that we're solving problems. But then it's this interaction that brings us to the real world. So it's a team. And that's what's most exciting about this area of work.
Yes. You have another question?
One more. What would you say to young women who would like to become a scientist?
Oh, go for it is what I would say, AnnMarie. So in a few years, everything is going to change, right? How we do our science and the tools and technology is going to be different. The questions are going to be different. Peanuts are not going to go away anywhere, but the kind of problems that we will have in producing food is not going to go out of fashion. Let me just put it that way, AnnMarie.
Mm-hmm.
So you want to become a scientist and solve real world food problems, nutrition problems, not just in the United States, but across the world. There's a whole world waiting out there with different problems, new problems. And there's always a need for bright minds like you to come up with solutions, new solutions. So I would say, go for it.
Awesome.
That's awesome. Any more, AnnMarie?
No.
Those were the hard hitters. Dr. George, we appreciate you for joining us today and sharing your wealth of knowledge. If somebody wants to follow up maybe on some of your resources or contact you, how would they go about doing that?
Oh, well, the easiest way, it's easy to, either look me up or, it's my email is Sheeja George at ufl.edu. And, we are on our website, the NFREC website or the UF IFAS website. All of that is out there and it's open information. You can contact any of us. And then if anybody contacts me, I'll be happy to connect you all with the right experts. Again, I'm not claiming, that's how we operate here. We connect people. And so it shouldn't be difficult at all. So feel free to.
You're clearly very friendly, very knowledgeable, easy to talk to, willing to share.
For sure.
And that's impressive. That's really, really nice. So thank you.
So for all of our
you.
listeners, we'll link the website in the show notes. So check those out. Again, we've been joined by Dr. Sheeja George, research coordinator and biochemist with the North Florida Research and Education Center through UF IFAS out in Quincy. She brings teams together and they solve real world problems with incredible research projects. So we appreciate your time. It's incredibly valuable. And we just appreciate you. We also appreciate Miss AnnMarie for joining us here in studio today. She brought some great questions, and we appreciate her. We look forward to having her on many more episodes, I hope. She's done a great job, but as always, we were led by our fearless leader, Laura Fowler Goss, and this has been the Florida Peanut Podcast. Thanks for joining us, and we hope that you have a wonderful day.
Thank you.